The objective of this lesson is to learn how to write really large or really small numbers in a much easier way, and also to be able to compare two numbers that have been written in scientific notation. Scientific notation makes it easier to write and manipulate very large or very tiny numbers. I don't know about you, but I would rather say 97.7 times 10 to the 22nd power rather than say 97 septillion 700 sextillion atoms. To express a number in scientific notation, your first step is to put the decimal after the first digit and drop any zeros. Then, to find the exponent, count the number of places from the decimal to the end of the number. So to put 97 septillion 700 sextillion into scientific notation, you would first put the decimal after the 9. Drop all the zeros, which would give you 9.77, and then, since you have 22 places between the decimal and the end of the number, that would be your exponent, 22. So a couple of important things to remember when writing a number in scientific notation is to move the decimal in order to get that number between 1 and 10. Then you drop any extra zeros. Finally, find the exponent by determining how many places you had to move the decimal in order to get that number between 1 and 10. So in this example, you see you have 709,000. So where does the decimal need to move to get that number between 1 and 10? Between the 7 and the 0. Then you rewrite the number without any extra zeros, which gives you 7.09. Then you set up the scientific notation by adding times 10. And then to find the exponent, you have to think about how many places you had to move the decimal in order to get that number between 1 and 10. And in this case, the answer is 5. So 709,000 written in scientific notation will be 7.09 times 10 to the 5th. In order to write 85,000 in scientific notation, the first thing you need to do is move the decimal to get the number between 1 and 10. In this case, you need to move the decimal between the 8 and the 5. There we go. I was having a difficult time with that. Then you drop the zeros, and that, of course, would give you 8.5. The next step is to add the times 10. And lastly, you need to find the exponent. In this case, since the decimal had to be moved 4 places, your exponent would be 4. So that would give you 8.5 times 10 to the 4th power. So 85,000 written in scientific notation is 8.5 times 10 to the 4th power. So sometimes you're going to have a positive exponent, and in some cases you will have a negative exponent. An easy way for me to figure this out, whether to know my exponent should be positive or negative, is to look at whether the number gets larger or if it's getting smaller. If moving the decimal makes the number larger, then your exponent is positive. If moving the decimal makes the number smaller, then your exponent is negative. This is another example of scientific notation. Since the number is smaller than 1, you already know that your exponent will be negative. You go through all of the same steps we talked about in the previous slides to arrive at your answer, which, as you see, will be 8.11 times 10 to the negative 4th power. So you would work through this next problem in the same manner. Where does the decimal need to move to get the number between 1 and 10? So your answer would be what? Between the 5 and the 3. Then, of course, you'd write the number without the zeros. And then you set up the scientific notation. Okay, so now you need to think about how many places the decimal point moved. And that would be 4. Will the exponent be positive or negative? Are you making the number smaller or bigger? Since you're moving your decimal point to the left and you're making your number smaller, it would be negative. So then, of course, your answer is 5.3 times 10 to the negative 4. To convert a number from scientific notation into standard notation, use the exponent to determine how many places you need to move the decimal and in which direction. So in this case, you know that you're moving the decimal 5 places. And since the exponent is positive, you are making that number bigger. So what works best for me is to think that a positive exponent will make the number larger and a negative exponent will make the number smaller. If it works better for you to remember that a positive exponent moves the decimal to the right and a negative exponent moves the decimal to the left, then that's fine. Use whatever method works best for you. So in this problem, you have 2.7 times 10 to the negative 3. So will your decimal move to the left or to the right? The exponent is negative, so it moved to the left. Then you need to think about how many spaces the exponent will move. Negative 3, moving to the left, 3 spaces. So you're left with and that's your answer. So in order to compare numbers in scientific notation, you will use division. So in this case, you would divide the larger number by the smaller number. You start by dividing the coefficients being 6 and 3, of course, and if you divide those, you get the number 2. Then you subtract the exponents. So negative 2 minus negative 8 would give you 6. So you're left with 2 times 10 to the 6th. So again, we subtract exponents when dividing. Work this problem on your own, remembering to divide the larger number by the smaller number. Be sure to start by dividing the coefficients, then subtract your exponents. Division with scientific notation definitely looks intimidating, but if you follow the steps, it is actually quite easy. In this section, you were supposed to work these problems on your own. Obviously, the problems have already been done for you. So look them over and make sure you understand the process. Scientific notation problems will be on both the quiz and the benchmark.